Hey everybody, Jacob Lebrecht here, and today I want to give a quick presentation on design patterns. And to start off, we will actually not be talking exactly about design patterns. We'll start off with what is a pattern. So, as you can see here, the dictionary definition is a particular way in which something is done, organized, or happens. And I'm sure we're all well aware of what a pattern is. So what this means in terms of OOP. So in OOP, as I'm sure you all know, many problems occur repeatedly. So to help solve these problems more efficiently and better, design patterns have been created and documented to help us make the code better, more maintainable, and more OOP even. So as software engineers, it is our job to recognize these patterns, where they fit, and where we can use them when they present themselves. That being said, as I'm sure we can all see with this pattern, it's fairly easy to pick up on. 1 plus 2 is 3, 3 plus 2 is 5, etc., etc. So that was an easy pattern to pick up. But what if I showed you this one? Many of you may have been able to figure out that this is the Fibonacci sequence. Not the beginning, but I don't want to say middle, but later on in the Fibonacci sequence. So the point I'm trying to make here with this is patterns take time and work to notice. While you would have seen this one very easily, and I'm sure if I'd showed you 1, 1, 2, 3, 5, 8, 13, you probably would have picked up on the Fibonacci sequence. But they won't always be that easy to recognize. And so they will take work, they will take time. Don't beat yourself up if you don't get it right away. Some general advice is, again, recognizing the patterns will take work and time. I myself still don't feel 100% comfortable with design patterns. So seek out information from multiple sources. I know David and myself, we recommend Christopher O'Crovery videos as much as we can, but there are other sources out there that provide even better explanations, or explanations that person A will get and person B won't get anything from. So seek out their information from multiple sources. There are multiple ways to present these things and multiple ways to do them where they're still the same pattern. Don't give up if it doesn't make perfect sense, and as always, have fun with it. With that being said, we'll dive right into the first pattern, the adapter pattern. So the purpose of this pattern, this is from the Gang of 4 textbook, Elements of Reusable Object-Oriented Software, is to convert the interface of a class into another interface that the client expects. Allows for classes to work together that wouldn't ordinarily work together because of incompatible interfaces. Now, as I'm sure we have all seen at this point in our lives, this is a 3.5mm audio adapter to a USB-C adapter. I'm sure we're all familiar with a few years ago now when phones stopped having the 3.5mm port on them. So if you wanted to use your headphones to listen to music, you had to have this adapter to plug it in. And it's similar to how it works in code. So with that being said, let's take a look at some example code. And as it says here, the example code can be found here. It might be under the development branch, it might be under the Adapter J. Lebrecht branch, but just feel free to peek around those branches anyways. So as you can see here, we've got the adapter package, and let's look at headphones. So headphones is representative of our headphones, and they can work with any audio jack iPhone. So let's take a look at that audio jack iPhone. It's got an audio plug-in method, and I'm willing to bet that the iPhone 5 subscribes to this interface, and it does. The audio plug-in, it'll print out a little message whenever you plug in your headphones. And the iPhone X does not subscribe to that. It subscribes to the USB iPhone, which has a USB plug-in. So, to account for this, we make an adapter. And we wrap the iPhone X inside of the USB adapter, which does subscribe to the USB audio jack iPhone, which makes sense in real life. This adapter, let me go back, you would be able to plug your headphones into this. So it's the same concept here. We're plugging the headphones into the adapter, which themselves can plug into the USB iPhone. And so then in our code, where's main? We're able to make our headphones. We're going to upgrade our phone to an iPhone X, which, let me come back over here to the USB adapter. So you could theoretically pass in the class you want to wrap. In this case, I've just got the one class I'm wrapping, so I do have a default constructor which sets this iPhone equal to an iPhone X. But if we go back to main, so we start off, we've got our iPhone 5, we're listening to music, and then we decide to upgrade to the iPhone X, and so we make the headphones iPhone be the USB adapter, which is then wrapping the iPhone X, and we can call headphones.listen, which just calls the iPhone audio plugin, which calls audio plugin, which is going to call iPhone USB plugin. And so that's a really simple explanation of the adapter pattern. With it, you can, I guess I can run it real quick. We do have these set up to where you can Gradle run. If you just do Gradle run, let me do quiet, and you can see the examples run. But this is a very simple explanation. You can wrap much more complex patterns or much more complex classes to make them work together. It is a very powerful pattern, as sometimes you won't be able to just go in and adjust code. For instance, on the iPhone X, so we could have just gotten rid of the USB iPhone here. We could have refactored this to make them both subscribe to just a plug-in method, and that would have worked. But you won't always be able to do that. For instance, if you're using an external library which you don't have access to change, obviously you can't change that. So those are when you'd want to use the adapter pattern, basically to wrap something that you want to use in a place that it wouldn't work, if that makes sense. And a very important note is that oh, I apparently forgot to finish this slide. A very important note, though, is using this adapter, you should not need to change the underlying behavior of the class you're adapting. And as I said, in some cases you can't. So with that being said, we'll move on to the next pattern, the null object pattern. So the null object pattern is a really interesting pattern to me. Sorry. It is a very simple pattern that can do a lot. The most simple example, as I'm sure some of you have seen something like this in your code, function, where you pass something in, and if it's null, you do this. Otherwise, you do something else. So the simplest way to get around this, or the simplest use of the null object pattern, I guess, would be to make a none animal. make a, let me pull up IntelliJ. So what was that name? That was called print name. Oh, get name, sorry. So we'll do public string get name. And we'll return nothing. A non-animal has no name. That's the most simple use. So then with that, we can get rid of this if statement here. I went back or forwards. I can get rid of this if statement here, and then when I call print name, it just prints a.getName. And if a is a non-animal, it'll print nothing. So where does the null object pattern come in? I guess I already just discussed it a little bit. So as it says, the idea is to, instead of checking for none null, we make a null animal class that will subscribe to that interface that we're having to check for none, null, nil in. And with doing this, we can encapsulate a lot of that logic that we use when we do check for none or null. And from a code coverage and refactoring point of view, this can even make our code less coupled and easier to read and follow. So let's look at a code example. This code example has been borrowed from a presentation given by Sandy Metz at RailsConf 2015. And I forgot to update this slide as well. I'm sorry, guys. I highly encourage watching her presentation. She'll go over a lot of what I've gone over and more. Her example is in Ruby, so if you do want to watch her video and follow along with my code on the repo, which I will update in this slide right here, and it'll also be on the description of this video. I highly encourage y'all to watch it. She does a really good job of showing the power of this pattern and also why you want to use it. It's about a 30-minute long video. Again, I highly encourage you all to watch it. Let me go ahead and check out the null object pattern branch, and we'll dig into this. So in her video, she talks about a old tale called the house that Jack built. In this, let me see, abstract house. So in this tale, and there's more lines in this. I didn't want to clutter the screen with the lines to the story. The house that Jack built, the dog that worried, the cat that killed, the rat that ate, the moth that lay in. Basically, it's an old kid's tale where you add a line each time you tell the story. And so, in her example, she is given a project to do a program that'll print this to recite the tale. So we have the abstract house. Where's concrete house? I'm getting a little ahead of myself, actually. So you make your class house, and you have your recite method, you have your data, and it works perfect. But then your bosses come along and they want a random house, which will do it in a random order. So you inherit from house, you add another method, or you override a method, and boom, it works. But then they want echo house, which does something else. So you inherit from house, do the same thing again. Then they want random echo house. And as you can see, it just keeps compiling or piling on to where your inheritance and polymorphism, or your inheritance structure, doesn't really work out anymore. So we use the null object pattern with while abstracting out the behaviors. So instead of having the classes themselves take care of the ordering and the formatting and etc., we have an orderer interface which has order, formatter interface. The other example she used was the echo house, which will format the data in a certain way. So she brings up an interesting way of solving for this by abstracting out the behaviors. We're going to have the orderer and the formatter, which will format the text in a certain way. As you can see here, we have the echo formatter, and we have the orderer, which will order the text in a certain way, which, as you can see here, we have random order. But what if we just want a regular old house, like the original example? So for that, we have the default formatter, the default orderer, which these could be considered as null formatters, null orderers. This goes back to her main thing that nothing is something. So we have this, that it just returns whatever you pass into it. On the formatter, we have this, that just returns whatever you pass into it. So this is just an example of how powerful the null object pattern can be. So with this single concrete house, I'm able to create what would have taken 4 or 5 classes if I hadn't used the null object pattern, coupled with abstracting out the behaviors, the order, the formatter. So with this, as you can see here, I've got a default house, which is just your regular original house. I've got random house, random echo house. And doing it this way, I'm able to inject whatever order formatter I want. I'm able to have just this single house. I don't have all of this inheritance that I have to keep track of. I don't have to have conditionals for checking what type of house it is. I just have this concrete house, and it orders it and formats it however I want it to. As with the other one, we can still Gradle run quiet. As you can see, we have the regular house, this is the multi-lane, the house Jack built, the random order, which is randomized, the echo house, which will duplicate each line, and then the random ordered echo house, which will duplicate each line and have them in a random order. So again, I highly encourage you all to check out this video. Oh, I don't know where my other one went. I highly encourage you all to check out Sandy Met's video. It's very interesting. I think I've seen it 2 or 3 times at this point. And again, if you do have issues following the Ruby language, an example she gives, this code, which will be on GitHub, is pretty much a one-to-one replica of her example, except for it's in Java. One thing I wanted to go back to was earlier in the video I mentioned that we do have less house classes. That is not the main purpose of doing it this way. In fact, I'm sure if I coded this out with using inheritance for the various class types, the various house types, sorry, you'd probably see that we have about the same, if not more, code doing it this way. But the point of this, doing it this way, is that it makes our code easier to maintain. We can add more behaviors to the houses much easier. If we wanted to add a new formatter or a new order, we could do that very easily. We wouldn't have to worry about who we're inheriting from, who we're overriding. So I just wanted to circle back to that Yes, we do have less house classes doing it this way, but that is not necessarily the point of doing it this way. Thank you, guys.